We are combining like terms and classifying polynomials today. Go ahead and throw your name on here. It is currently second hour. Hey, the first thing I have is I have this little picture that I copied and pasted from Google Images of the parts of an algebraic expression. So, something that's important to know, you will not see an equal sign this unit. We are not solving any equations this entire unit. Everything is an expression. We are going to simplify expressions today. Tomorrow, or not tomorrow, but Monday we will add and subtract expressions. Next week we'll also multiply expressions. And then we're going to factor expressions. Factoring is the word we use for dividing. It's similar to dividing, but you have to decide what you're dividing by. So we will be adding, subtracting, multiplying, and factoring expressions. We will never be solving an equation this unit. There are no equal signs in the polynomial unit. So with that being said, these are the parts of an algebraic expression. So if I've got this algebraic expression here, 3x squared plus 4x minus 12, first of all, that has three terms. So the terms of an expression are the parts that are added or subtracted together. So 3x squared is one term, 4x is one term, negative 12 is one term. Within our terms, you can have coefficients. Coefficients would be the 3 and the 4 here. Those are the numbers getting multiplied by the x's. And then our variables are our x's, and they have different exponents, so x squared and just x. And then a constant is a number by itself. So we want to just be able to use that vocab and say, oh, put your constants at the end. Add together your coefficients. Multiply together your coefficients. Add your exponents. So you guys will hear those words throughout the unit. And so that's why I wanted to just introduce them to you here at the beginning. Once we get our like terms combined today, we are also going to be classifying our polynomials. There's a lot of vocab today, but you've got your note sheets, and we'll put this on your note card as well. We are going to classify polynomials by two different things. So we'll classify it by a degree and by the number of terms. So the degree is the highest exponent. The highest exponent is 1, it's linear, 2 is quadratic, 3 is cubic, 4 is quartic. So that is based on the degree of the polynomial. And then we'll also classify on the number of terms. So like this one here has 1, 2, 3 terms. So if it has one term, it's a monomial. Mono means one. Monogamous means you're married to one person, or in a relationship with one person. 2 terms is binomial, so think a bicycle has 2 wheels. 3 terms is a trinomial. A tricycle has 3 wheels. And then 4 or more terms. So once you get to 4, we just say, oh my gosh, you got a lot of terms. So 4 or more terms is a polynomial. Poly means many, so like polyester is many fibers. Polytheistic is a religion that believes in many gods. So poly means many. Okay, so here are the steps for what we are actually doing. We are combining like terms today. Like terms have the exact same variable and exponent. So you can combine your x to the fifths with your other x to the fifths. You can combine your y to the thirds with your other y to the thirds. Like that. We are going to combine those like terms by adding together their coefficients. And then while we are doing that, our final answers need to be in standard form. You should just put your answers in standard form while you're working, so you don't have to rearrange them at the end. Standard form is highest to lowest exponent. Do you have the wrong sheet of paper?
Yeah.
I am sorry. Swap that up. So the highest to the lowest exponent, and then all your constants go at the end. So it'll be like x to the 5th, and then x to the 4th, and then x to the 3rd, and x squared, x to the 1st, and then your constants go at the very end. So highest to lowest exponent, constants at the very end. Okay, does anyone else have the wrong sheet of paper? Because since I cut these in half, that means if one person has the wrong sheet of paper, someone else might as well. And it might still be in this giant stack. Everyone else got the note sheet? Okay, I'll find it later, I guess. Alright, so go ahead and flip this over. We've got 4 examples on the back, I think. Here is my strategy. Oh, I found the extra copy. Here is my best strategy for for combining like terms, and it is an elaborate set of underlining things. So I look at my exponents and I underline it for however much the exponent is. So the first thing we're going to do on these is combine like terms. So we've got 5x to the third and 2x to the third. We can combine those together. So I'm going to underline each of those 3 times for the third power. So it helps me keep track of things. So 5x to the third and 2x to the third, we combine those together. And that is going to give us 7x to the third. We are adding our exponents. Then I'm going to go put 2 lines underneath everything that's an x squared. That right there is the only x squared term I have. So if he has no one to combine with, he just stays by himself. That's going to be plus 3x squared. Then I've got this negative x and this 7x. X by itself is the same thing as x to the first. So there's an imaginary first exponent there because there's 1x. Right here, there's also an imaginary negative 1. So this is negative 1x plus 7x. So negative 1 plus 7, same thing as 7 minus 1. It's going to give me 6x. And then I'm out of ways to underline things, so I always do a zigzag on that one. So my constant goes at the end as negative 6. So if there are terms that are the same variable, same exponent, you can combine them together. If there's only one of that variable and exponent, you just keep it separate. So we have now combined all of our like terms. Any questions about that guy? Right. The next thing that we're going to do is we are going to classify it then. So we look at 2 things. We look at the highest exponent, and we look at how many terms there are. So the highest exponent here is 3, and there are 1, 2, 3, 4 terms. So the degree, the highest exponent is 3, there are 4 terms. So we use our table on the front. We've got a degree of 3, so that is cubic. And there are 4 or more terms, so that is polynomial. So I put 2 blanks here because we're going to classify it based off of 2 things. This is a cubic polynomial. Your first word is always going to be the one that describes the degree, because this is an adjective and this is a noun. And in the English language, adjectives usually go before nouns. Flipping it the other way would be like saying this is a car red instead of a red car. It doesn't make sense, okay? So the term based off the degree goes first, and then the term based off of the number, or the word based off the number of terms goes second. Okay, let's move on to the next one. So we look through, and we always want to just go from highest exponent to lowest. So the highest exponent I see is x squared. So this 13x squared and this negative 4x squared can get combined together. 13 plus negative 4, or is the same thing as 13 minus 4. And that is 9. So I've got 9x squared. Then I can combine together my 2x and my 2x. So 2x and 2x combine together to be 4x. And then I've got negative 3 and 15. Those can combine together. Negative 3 plus 15, or 15 minus 3, is 12. All right, what is the highest exponent I have here? Somebody said it. Say it louder. 2. Okay. Highest exponent I have is 2. How many terms do I have? How many parts do I have? 3. 1, 2, 3. So a degree of 2, 3 terms. Use your notes until you get them memorized. This is a quadratic, because degree of 2 is quadratic, trinomial. Quadratic trinomial. Be careful on spelling, especially for quadratic and quartic. They start the same way and end the same way, but the middle syllable is different. Well, there isn't a middle syllable in quartic. All right, any questions right now? Okay, let's keep going. Something wonky happens in the next one. So in the next one, I've got a bunch of x squared, so I'm going to combine them all together. So I've got 3x squared, negative 9x squared, and 6x squared. What is 3 minus 9? What is negative 6 plus 6? 0. Okay, how many x squareds do I have left then? So 3 minus 9 is negative 6. Negative 6 plus 6 is 0. I have none. Okay. If I were to write down x squared, that would mean that I have 1x squared. I do not have 1x squared. I have 0x squareds. So those completely cancel out. They are not part of your answer at all. So if it helps you to remember, just cross them out. Then I have my x and my 2x. Those can combine together, so that would be 1x plus 2x. That is 3x. So my answer on this one is literally just 3x. All right, degree. This x does not have an exponent on it. If it did have an exponent, it would be an imaginary 1. So this is a degree of 1, which according to my table is linear. And then I only have one term, so it is a monomial. This is a linear monomial. So if something cancels out, it's not there at all in your answer. We need so many scam calls. All right, last one. We can combine together all of our x to the fourths. So you've got 7x to the fourth minus 2x to the fourth minus 4x to the fourth. 7 minus 2 is 5. Minus another 4 is 1. So that leaves me 1x to the fourth, or just x to the fourth left. And I've got this 5 and this negative 8. 5 minus 8 is negative 3. So I've got x to the fourth minus 3. Okay, my highest exponent here is 4, and I've got 2 terms. So if my highest exponent is 4, that's quartic, and then 2 terms is a binomial. So you can mix and match these. Use whichever one you need for the degree, whichever one you need for number of terms. This is a quartic binomial. Hey, go ahead and glue these notes into your notebook. I'm going to go ahead and stop this video.